Hello, so this is the second in my series on blockchain and Bitcoin for beginners. And as I mentioned in the first video, it's going to be a kind of classroom style, hopefully. So I'm joined by my girlfriend here, Nadisha. So she's going to
Hello.
keep me right. If I say anything that doesn't make sense from a beginner's point of view,
Mhm.
she's going to pick me up on it. You're pretty new to this stuff, right?
Yeah.
But she has seen the first video.
Mhm.
It was good, wasn't it?
Yeah.
Yeah.
Good.
Okay. Not too convinced there. All right. So basically, just to give you a quick overview of what we're going to cover today. So the first video was more about a physical, real-world example. Obviously, blockchain is predominantly a kind of electronic concept, and so I think we'll sort of extend that and explain how that actually works in the real world. Then we'll go on to talk about one really important concept, which is hashing, right? Which is basically, you'll see it all over Bitcoin and everything. It's quite straightforward, but it's really important to understand it. So we'll get it done early on, and then we'll show a real life example of an actual blockchain in action. So which is the blockchain.info website, and that's actually a real world snapshot of the actual Bitcoin blockchain, and you can see the Bitcoin transactions appearing. You can see the transaction blocks, etc. So it's a good way to sort of round off the first part where we've actually kind of introduced the basic concepts. Okay, so I'm just going to recap where we got to in the last slide of the previous video. Okay, so we had our guy working in the bank, storing checks away in boxes, right? And then they decided, okay, we're not going to trust this guy to do this job. We're going to actually give the job to the identical job to four different people, and they're all maintaining the same stash of checks in boxes, so that not one of them can actually go back and manipulate or reprocess all of the boxes from, say, number 2 onwards, right? And we saw an example of how this guy could manipulate the system, but in this scenario he can't do that. So that's where we got to in terms of the last slide. So the key thing is, in the real world, on an actual computer network, what is a blockchain? Well, a blockchain is really just it's a bunch of computers, right, that are all talking to each other over the internet, right? So these are just like your people who are working in the bank, right? So, and they're all talking to each other, and they're all receiving in real time every transaction that is happening, right? And now when I say any transaction, let's be clear about that. So there are many different blockchains, right? You can create your own blockchain. So the definition of a particular blockchain is basically who is on the network, right? What software they're all running to process this particular type of transaction, and then actually what type of transaction are you talking about? So for example, probably the most common or the most famous blockchain is the Bitcoin blockchain. Now, the Bitcoin blockchain is basically one example of a network of computers who've all installed the Bitcoin software, right? And what that software does when they install it is automatically that software is basically listening for every single Bitcoin transaction. So every transaction of type Bitcoin that gets broadcast onto the Bitcoin network will be received by any computer that has installed the Bitcoin blockchain software, right? Now there are other blockchains like Ethereum, like other cryptocurrencies, and how do you distinguish that blockchain and Bitcoin? Is basically, well, it's separate software you install, right? And when you install the software, you register your computer as a node on the network, and from that moment on, your node will be receiving all of the messages of that particular type. So if you installed the Ethereum software, you'll hear about Ethereum transactions, right? And your Ethereum software, what all of these software do essentially is keep a log of all the transactions they receive, and basically and these transactions are all arranged in blocks, just in the same way that our check guy who was putting checks in boxes was sorting them in interdependent boxes, so that there's no way ever you can go back and change one of those checks. Just like in this example, these are electronic transactions, but there's no way, because of the way that every node stores an identical copy of the complete transaction trail grouped into boxes, there's no way they can go back and ever change that, right? And we'll go into more detail about how that happens. Okay, so so basically, I want to talk about a bit about hashing, right? So in the first video, right, we talked about this concept of a scales, like so accurate that you can literally just, weigh every single atom and pick up every single piece of ink on the page, right? Now, that was a bit of a weird analogy, but in electronic terms, this hashing algorithm, what it is, it's basically, so it's an electronic equivalent of our magic scales, right? So what we're saying is anything that can be represented as a, electronically as a, a digital asset, right? It could be a photo, could be a movie file, could be a text document, could be just a string of characters. You can put it through this mathematical function, right, called a SHA-256 hash. There are other types of hashing algorithm, but SHA-256 is basically one that's very commonly used at the moment. You put it through this mathematical function, and out the other end, you basically get it's a 256-bit string, okay, in binary, right? So like all ones and zeros, right?
Yeah.
256. And a common way to sort of represent that in a more human readable way is to sort of encode these characters into groups, and so you can write them as numbers and letters, right? So normally, you'll see this all over the place. A SHA-256 hash, right, will be represented as a 64 numbers and letters grouped together, right? But the most important thing, I'm not going to go into too much detail, just enough to actually understand, how blockchain uses hashing, is that the idea is that no two documents or no two assets will ever give the same hash, right? That's not 100% true in the sense that theoretically, because this hash is only 64 characters long, and there are infinite, documents that you could put through the algorithm. Obviously, there are collisions out there. There are documents out there that could theoretically produce the same, but it's so remote, the chance of doing so, that it's considered impossible, right? And
even if it's the same information, or
so if I perform the hash on the same document each time, then I'll always get the same hash.
right, yeah.
But if I modify even one single character, let's say in a text document, the hash I get will be completely different.
Right.
Like not just one letter different, it'll be totally and utterly different, right?
Okay.
So, and this is used all over the place to basically, it's like literally a way to check whether the contents of something have changed. Just like putting it on those scales, right? The way we made sure that the boxes hadn't changed or the checks hadn't changed.
Yeah.
This is basically, it will detect the smallest possible detail of the hash. So I'll give you a quick example of how that works, right? So I've got some sample documents and I'll just show you quickly, right? Right, so just to give you a quick example, right, on the left-hand side of the screen here, I've got a text file, which is basically a freely distributable complete contents of Alice in Wonderland, the book, right? Now that's the text file that's saved on my local system.
Yeah.
Now I can use this. This is one of many online tools that basically say, give me an input file or a string or whatever, and hit the hash button, right? And it gives you all of the hash values, right?
Right.
So these are all different ways of hashing, but as I said, we're using SHA-256. That's the one that's used in Bitcoin for Bitcoin hashing, right? So I've uploaded this file here, right? So if I do hash, right, and I can see down here, okay, need to choose a file. So click this again, choose it, and hash, right? So if we just make a mental note, right, that the last three characters are B6C, right?
Yeah. You said mental note, I got a bit worried.
So then what I'm going to do is I'm just going to put a space at the bottom of this file, right, and save it, right. So B6C, yeah. Choose file again, and now the hash has changed to 2E2, right? And actually, if you go back, you'll see that every single character in this thing would have changed. So just by inserting literally one space in this document, right, I've altered the entire hash. So it's a way of saying. So if you think about it, if this is used all over the place, but if you're sending this document, you might say, okay, I'm going to create the hash, send the hash, and then when you receive the document, you hash it as well and make sure that they haven't changed, to ensure that nobody's changed their document. So if we just choose this one again, last time, just to make sure, and we should go down and we should see it's gone back to B6C, right? So that's illustrated, hopefully, that basically each, as long as the input into the hash function is identical, it will always produce the same hash, right? But if I change even one tiny little bit for the input, the hash is going to be completely different, right? So that's really all you need to know about hashing for Bitcoin. It's a way of, let's say, representing uniquely an input of some kind that is electronic. Yeah. Just as we use the scales in a slightly silly example of representing uniquely, like perfectly uniquely, something that in the real world, like something physical, right? And that, so the reason, so if you can probably figure out by now, so the reason hashes are used in the sort of blockchain world is to say, well, our transactions in a blockchain world, they're not going to be physical pieces of paper, they're going to be electronic documents, right? And that electronic document is going to be a representation of various types of transaction. It could be a Bitcoin transaction, could be an Ethereum transaction, could be a, like whatever digital currency transaction. And it doesn't have to be, currencies. It could be, you could use the blockchain to audit transactions of any type, as long as it can be represented as an electronic document, as long as you can hash it. And then what is it? You just need to be able to group those transactions into blocks. Right, into batches, and then also you need a network of computers who are all listening for those transactions and storing the blocks, right? So anybody can create their own blockchain at any time. Okay, so that's hashing, right? So basically, I said that we'll sort of finish off with a quick sort of overview of the blockchain.info, right? Just to show you how Bitcoin transactions themselves are grouped into blocks, right? And hopefully this will make it very clear. You'll see the exact kind of parallels between the analogy we talked about with the checks and the actual Bitcoin blockchain. I'm not going to go into what the Bitcoin transactions mean. That's for future videos, right? But this is just hopefully like an appetizer for you to basically see. Okay, so this is a real blockchain, and it's the actual Bitcoin blockchain as well, which is kind of cool, right? So if you think about, so I'll come back to this table in a second when we go over so basically there's a table here with the equivalent entities in the blockchain.info site and what they correspond to in the real world example, right? So blockchain.info. Now the first thing I want to really hammer home about blockchains in general is the concept of decentralization, right? So what I mean by that is that if you go to the server, let's go to this. Now, blockchain.info is a website, right, which is obviously running from a server, which has a complete record of all of the Bitcoin transactions. These are live Bitcoin transactions coming through, just like in the HSBC bank, the guy was receiving his checks, through into the back room all the time. So these are live, right? But what I'm trying to say is that the blockchain website, the blockchain.info website here, which is only about Bitcoin, this has a complete copy of the Bitcoin transaction history, all the way back to the first ever Bitcoin transaction, right? And there's only one Bitcoin blockchain, right? Because that is the Bitcoin blockchain. So because Bitcoin is a type of transaction, just like Ethereum might be, but Bitcoin is a type of transaction, and those transactions are maintained in one entire transaction history, which goes right back to the very first Bitcoin, right?
Yeah.
So if you
Makes sense.
if you have, you can't have another blockchain for Bitcoin, because then if you're spending Bitcoins, it's basically, well, this new
There's no way
transaction,
of validating it.
yeah, like which blockchain would this transaction be part of? So it's basically, think of it like one blockchain per transaction type, right? And Bitcoin is one type of transaction that is, on the blockchain, right? So blockchain.info is basically one example, one server, one computer on this huge network of, thousands, hundreds of thousands, with, however many there are at a given time on the Bitcoin network. But each node, right, have a full copy of the entire transaction history. Blockchain.info is just one of them, right? So it's a really important point to hammer home, that it's not like, okay, blockchain.info is assimilating all of the history from all different nodes and everything, and and this is basically the only place where you can go and find all the transactions. Every single computer on the network has all the transactions. It's just that these guys here have basically put a nice website together that shows you, so you know how to browse through them, click here, click there, right? But every single node on the network has a copy of the entire transaction history, and this guy is just, they happen to have a nice interface to browse it, right?
Yeah.
Which is what we'll go and see now, right? So so let's have a quick look at this. This is very, very cool, quite self-explanatory. But if you remember in sort of HSBC, or I keep saying HSBC, but the world of the bank and the guy with the checks, he had boxes stacked on top of each other, right? These blocks, right, are our boxes, right?
I see.
So it's quite straightforward. So this is Bitcoin again, right? So right now we are on block number 416,067, right? So that is the number of blocks to date that have been processed in the Bitcoin blockchain, right? And you can see these are stacked up on top of each other.
How do you determine it's the end of a block?
Well, so
in this case,
this is just a list of accepted processed blocks, right? Now what's happening at the moment is that these transactions are coming in live. These transactions have not yet been stored in one of those boxes, right? They're just basically, so what happens is, and okay, we're going to go more into sort of Bitcoin mining and how the actual Bitcoin blocks themselves are processed and created. And
so that's for another video.
Yeah, but I'm not going. I'm going to try not to dodge the question too much. So basically, you'll see a new block approximately every 10 minutes, right? So if I waffle on long enough, you'll probably see a new block appear there, right? So,
but it's not the end of a block, is it?
No, these are done and dusted blocks. Like, think of these as boxes with the lid closed.
Yeah, because I can see a different number of transactions in each block.
Yes. Oh, yes. Okay. So, but that's just like with the checks. We didn't say that there's going to be exactly the same number of checks in each box, right? Our guy who's storing the checks, he was basically saying, okay, each week I take whatever checks have come in this week. There could be 900 one week and 1,000 the next week. So even in that example, you'll never see the same number of transactions in each block.
Is it the size?
It's the time interval, more or less. I'm going to expand on that more in future, but generally speaking, all of these nodes on the network are basically they're working on basically sealing the next box of transactions, but then they do so in the deciding factor is time. So basically every 10 minutes, no matter how many transactions have come through, you'll generally get a new block. Now, I'm deliberately skirting the issue a bit because how it's decided which node is responsible for saying this is the new block is something that's quite complicated, or not complicated, but it needs a solid understanding of Bitcoin, right, before we get there, right?
Okay.
So, but just suffice to say, each node, or lots of nodes, are competing on the Bitcoin network to be the one who successfully publishes or decides, okay, this is the new block. Then they send that block around, and it gets stacked on top of everybody else's copy, right? So we will go into much more detail on this later, but I just want to sort of give, this is more like nuts and bolts. These are blocks, these are transactions. If I go, and just sort of tying it back into the first video. So if we take, this is the most recent block, right? And the height, which is basically the ID. Remember in the box stack I had ID1, ID2, right? So this one, click on this. So this is really interesting. This is like the home page for this block, right? And it's really straightforward. I mean, I'm not going to go into every single detail here, but
I can see the hash, the previous block.
Right, exactly.
Right.
So this is, if you remember, like we had a label on the box where you say, okay, put the thing on the scales and get the perfect representation of what that thing is, and that's the hash, right? So basically, you take that block, and then you put it through that hashing algorithm. You could use that website there. It would do exactly the same thing, right? If you had that block represented as a big file. And that's what you put on the label on the outside of the box, right? That hash accompanies this block everywhere and says, okay, if you're validating this block, make sure that the hash is this, right? So if anybody ever changes anything, like within this block, like if anybody tries to say, okay, I'm going to remove this transaction from the block, the hash is going to change. The other thing we mentioned, which is kind of cool, is the previous block. So you remember in the first video we had a cover sheet inside the box, and the cover sheet you write the parent or the previous weight, right? And that's exactly what this is. This is basically the hash of the previous block. So if you see, so again, this is the label on the outside of the box. This is on the cover sheet inside the box. And the important thing is that the previous block is actually, because it's in the cover sheet inside the box, and that's put on the scales, the previous block is part of the hash. Right. That's how we maintain the interdependency between the blocks. Because if somebody comes along and tries to modify block 416067 and says the previous block hash is some different value, right? Because that changes the actual contents of the block, this hash will no longer tie up to this. And so the validation will fail, right? So that's it's quite straightforward, I think, and it's quite cool. And you can see again, so when the hashes, just to hammer home, so it was a SHA-256 hash, which means there are 64 letters and numbers, right? Now you notice that the leading 15 or so characters of this string are zeros, and we'll get to that in a second, right? But these are all letters and numbers, so 64 letters and numbers is what the hash looks like. And the last thing that's really cool is that you can see, this is just more like an appetizer, right? So you can see each and every transaction in this block, right? And this is the equivalent of our checks, right? What checks are in the box, right? And these are all the Bitcoin transactions, because obviously this is the Bitcoin blockchain, right? These are all the Bitcoin transactions, and basically there are, you can see here, there are how many transactions? Oh yeah, 2,135. So they list them all there. Now, we're obviously going to get into much more detail about what these transactions represent, and hopefully, in a few videos' time, you'll know exactly what this is actually about, understanding the Bitcoin model rather than blockchain, right? So Bitcoin's a great vehicle to learn about blockchain, and you need to know about blockchain to learn about Bitcoin, right? So this is the block 0, right? And remember I mentioned, so in the first video, the first box on the floor didn't have a cover sheet, didn't have a parent block, right? Because it's the first one. It had ID1, and basically you can see this is in the Bitcoin world. This is the first ever Bitcoin transaction, which is this one, right? It has one transaction. So the originators of Bitcoin, they basically had this was the transaction that started it all off, and every subsequent Bitcoin transaction and every single subsequent Bitcoin block descends from this particular one. So it's just quite cool how you can sort of, and if you had, you know, how many blocks were there? Like something like 460,000, right? This is the first one. And you can notice here, the hash is this. The previous block hash is basically just a nominal value. It's basically saying, well, there's no previous block, right? So, and then you can, if you had time, you can just click through,
Block 2, 3. Yeah.
right? And you can see how, and this is the complete history of Bitcoin.
All the blocks, yeah.
And that's another, just, you know, just to finish off, it's a really important point, is that this is a distributed ledger, meaning it's completely public. You can download the full ledger and you can see every single Bitcoin transaction that's ever happened is publicly available, and it's all in this shared block, right? And so yeah, that's block number 8. From there it goes all the way up, but you know, the history is completely sealed and can never be altered, right? And yeah, so that's pretty much it. Does it make sense?
Yeah, it all made sense so far.
Okay, cool. All right, so thanks for watching, guys. Any questions, comments, feedback, please leave them down below, and well, see you in the next video. Cheers.